Here we'll look at representing a function in three ways, essentially looking at a graph, a table, and an equation. So those are three ways to look at a function. So if we're given the following graph, we want to verify whether the graph is a function. Remember, to be a function, each x has at most one corresponding y value. So as we look at this, if x equals 2, we only get one y value of 3 here. If x equals 4, we only get one value for y, positive 7. There is not an x value that will give you more than one answer for the y value. So that is a function because each x corresponds to at most one y value. Okay, so to write the equation of this function, well, we can note that it's a line, so it's a linear function, which means y equals mx plus b. You need to find m and b, the slope and the y-intercept. So we can see that the y-intercept is here at -1. And if we count up 2 to the right one, that's our slope. So we know that y equals 2x minus 1. Okay, so the slope and the y-intercept at -1. Using f of x notation, instead of y equals, we have f of x equals. So there's your equation. Okay, I want to make a note that the function will pass the vertical line test. So if you imagine a vertical line, okay, remember vertical line goes straight up and down. So that would be a vertical line at x equals -7, x equals -6, x equals -5, and so on. The idea there is as you slide straight across the vertical line, so looking at the edge of my ruler as a vertical line, do you ever cross the function, I'm sorry, I shouldn't say function yet, cross the graph in more than one place? Well, when x is -2, we're at this point right here. When x is -1, we're at this point right here. There is never a time when you slide that vertical line from left to right, you never hit the graph at more than one spot at a time. So when x is 4, we're up here. If x is 2, we're right here. Okay, so the vertical line test will help tell you if you have a function. So to complete the table of values, you can either use the graph or use our equation. So with x and f of x, if x is -3, we can go to our equation here, put -3 in place of x, and that'll give you -6 minus 1, which is -7. Over here, when x is -3, we intersect the graph at -7. So when x is -3, we get -7. So if you go through and fill in the table for all those values, that's what our table will look like. So that shouldn't be too difficult to do at this point. Now we're going to look at using function notation with that table. And this is a source of confusion for many students. It says evaluate each of the following, f of -3. Well, remember, our function is f of x. So whatever you see in the parentheses is your x value. So what this is telling us is x is -3. Well, the x value is -3 right there at the top of the table. What is the answer? The y value is -7. So f of -3, when x is -3, we get -7 for the y value. Okay, the next one, f of 0, means that when x is 0, what is the y value? Well, when x is 0, we get -1 for y. And then f of 3, when x is 3, so when x is 3, we get 5 for the y value. One thing that students miss a lot on that, my explanation there probably made sense. When you start looking at this on your own, students will a lot of students will look at f of x and they'll see f of 3. And they'll think, well, gee, that means I need to do f of x and find 3. And they put an answer of 2 or x equals 2. The problem with that is when you see f of 3, that's function notation telling you that the x value is 3. When we go here in the table, that's a y value of 3. Remember that f of x means y. So f of 3, when x is 3, we're here in the table, we get 5 for an answer for y. So you got to be careful with that. Okay, in the next few examples, f of x equals negative 3. Well, now we're basically saying we don't know what x is, but we're saying the y value equals negative 3. Well, in our table, the y value equals negative 3 right here. So now, when the y value is negative 3, the x value is negative 1. So x equals negative 1. Okay, you can see for f of x equals 3. So again, that's saying that the y value equals 3. Y equals 3 right here. So the x value is 2. And do the last couple here, and I'll show you the answers. We get 1 for f of x equals 1. And then f of x equals negative 5. We end up with x equals negative 2. Now those two are a little different because notice that y equals 1. So f of x equals 1 means y equals 1. That does not show up in the table. But we have a graph and an equation we can use. If we use the equation, we know that 2x minus 1 should equal 1. So if you solve this equation, add the 1 to each side, so 2x equals 2. Divide by the 2, and you get x equals 1. If you looked at the graph, where does y equal 1? Well, the y value of 1 is when the height on the graph is 1, so that's that horizontal line there. It intersects our graph right here. Okay, so at this point, which happens when x equals 1. On the last one, when f of x equals negative 5, graphically, we can see that negative 5 is right here. So when you go straight across at negative 5, we hit this point right here on the graph, which is when x equals negative 2. So negative 2 is the answer there. If you use the equation, we know that 2x minus 1 should equal negative 5. So add the 1 and then divide by 2. So that's how you look at a graph using a table, equation, and graph.